This is the Math 2 lesson summary video for the lesson entitled Finding the Value of a Relationship. In Lesson 8, Finding the Value of a Relationship, the purpose of this lesson is to solidify our understanding of the ways to solve for an unknown value in a right triangle. We learn how to use inverse trigonometric relationships, sine inverse, cosine inverse, and tangent inverse to find unknown angle measures. We also discuss the differences between an angle of elevation and an angle of depression. Some vocabulary from this lesson is the angle of elevation, which is the angle between the horizontal line and your line of sight, or looking upward. The other vocabulary word is an angle of depression, which is the angle between the horizontal line and your line of sight looking downward. In our previous lesson, we learned the ratios for the sine, cosine, and tangent of a trigonometric function. Recall that the sine of theta is equal to the opposite side in the right triangle over the hypotenuse. Recall that the cosine, let's make sure we have, there we go. Cosine of theta is equal to the adjacent side to the reference angle in the right triangle over the hypotenuse, and that the tangent of the reference angle is equal to the opposite side of that reference angle divided by the adjacent side in that right triangle. We are first given a scenario in part 1 of this lesson where Andrea and Bonita are resting under their favorite tree. We are told that the angle of elevation to the sun is 50 degrees. Therefore, this here is our reference angle. And the length of the shadow of the tree is 40 feet, as shown in this diagram. We are then asked if they would be able to calculate the height of the tree using our current knowledge of trigonometry. So the height of the tree would be this side over here, x. The answer is yes. We are looking to find the length of the side opposite of the reference angle. So we can label this side the opposite and the side that is adjacent to the reference angle. Therefore, we can use tangent and write that the tangent of the reference angle of 50 degrees is equal to the opposite side, x, over the adjacent side, 40. Now, in the previous lesson, we've talked about how to solve that. In this case, we can multiply both sides by 40. So then x is equal to 40 times the tangent of 50 degrees. In our graphing calculator, recall that in order to use trigonometry, if you're working in degrees, you need to make sure that your mode highlighted is degree, so that we are calculating the right height. So I'm going to type in 40 times the tangent of 50, and this should give me the height of the tree. So the height of the tree is approximately 47.7 feet. In part 2, what's our angle, or what's your angle? We are given a scenario and then asked if we can find the measure of angle A, which is right here in the diagram. We are told in the bottom here that Bonita notices a sign to the -1 button on her calculator and wonders if this might work like an inverse trig ratio button. So let's see where she's finding that sign to the -1. If you notice above sign, there's a sign to the -1 in blue. So that sign to the -1 is actually going to always help us find the angle. Now, it could be the cosine of -1, or it could be the tangent of -1, just depending on what sides we're given and need to find in the triangle. this information would definitely provide the measure of the angle. Therefore, if we are asked to find the measure of an acute angle, we would use sine to the negative 1. Write this down. Cosine to the negative 1 and tangent to the negative 1. And we do call these the inverse trig functions. They do help us find the angle measure. So the difference here is if we need to find a side length in a right triangle, we would just use sine, cosine, and tangent. But if we need to find an angle measure, we would use sine inverse, cosine inverse, and tan inverse. So if we look to see what Bonita wrote down, we can see from where the reference angle A is, we have the side opposite, and we have the hypotenuse. So the trig function that uses opposite and hypotenuse would be sine. So we can write that as the sine of A equals 40 divided by 100. Now because we're trying to find an angle measure, we would use the inverse function and divide 40 by 100. So let's see what we get when we do that. Second, sine inverse, 40 divided by 100 is approximately 23.57 degrees, or we can say 23.6 degrees if we round to the nearest tenth. In number 5, we are asked to find all the unknown values of the triangle provided on the right. So let's do this together and see if we can figure out, using the information we know, what the missing angles and sides are. They tell us in part C the angle Y is 90 degrees, and we can see that because it is marked with a right angle. Little a is equal to 12 meters, so let's label that as 12 meters. Little b is 8 meters, so let's label that as 8 meters. So now that we filled in all the information, we are asked to find the other missing values. We can use Pythagorean theorem to find c, and we can do 8 squared plus 12 squared equals c squared. 8 squared is 64 plus 144 equals c squared, and we can do that math together. 144 plus 64, and then we need the square root of that answer. Let's make sure. Second answer. And I get approximately 14.4. So I can see here that my hypotenuse is approximately 14.4 meters. So we've now found little c. All right, so now they're asking us to find alpha and beta. So let's find alpha first. According to where alpha is, the reference angle, let's use opposite and adjacent. So we have the opposite and the adjacent side, and this will be the hypotenuse, which we now know is approximately 14.4 meters. So we can find alpha. Which trig function uses opposite and adjacent? Well, it will be tan. So we would write the tan of alpha equals the opposite side over the adjacent. And recall what we just learned in part 2 was that if we're asked to find an angle, we do have to use the inverse trig function. So we would do tan to the negative 1 of 12 divided by 8 to find alpha. Second, tan 12 divided by 8 is approximately 56.3 degrees. Now we have two ways, since it's 56, approximately 0.3 degrees, two ways to find beta. We could use another trig function, or because we know the sum of the angles in a right triangle or any triangle should be 180 degrees, we can take 90 plus our answer from the previous line. We get 146.3 approximately, and take 180 minus that answer, and that should give us the measure of beta. So the measure of angle beta is approximately 33.7 degrees. In part 3 of this lesson, we are told the difference between an angle of elevation and an angle of depression. An angle of elevation is from a horizontal line. I'm going to highlight here. Here's my horizontal line. If you look up from the horizontal to your line of sight, that angle in between the horizontal and the line of sight will be the angle of elevation. Likewise, if you are looking down, the horizontal to your line of sight is called the angle of depression. Something that's interesting about this diagram is we do know that I can drop this down here and there's my right triangle. Well, what we have here is we have parallel lines. And we have parallel lines. If I extend this here, that would be a transversal. If you recall from our previous units, two parallel lines cut by a transversal create congruent alternate interior angles. So these two angles should be congruent. Therefore, the angle of depression and the angle of elevation in the diagram should be the same degree measure. Looking at number 7, Andrea mentioned that her angle of elevation to Cibo Bonita was about 23.5 degrees. So that measure would be right here in our triangle, the angle of elevation. Bonita said that her angle of depression to Andrea was about 66.5 degrees. So Bonita is saying that her angle of depression is 66.5 degrees. Andrea agreed that it was an angle of depression, but said Bonita's angle of depression was also 23.5 degrees. We had to justify who was right in this case. If we examine this diagram and say the angle of elevation is 23.5 degrees, then since these lines are parallel and cut by a transversal, these angles must be alternate interior angles, which must be congruent. Therefore, both of the angles must be 23.5 degrees. It is not possible for Bonita's angle of depression to be anything but 23.5 degrees. Thus, Andrea is correct in that the angle of depression is also 23.5 degrees. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.